all to another session of Concept at Fingertips. This is Vidya, Physics faculty. In today's session, let us see the topic electric generator. So what is electric generator? Electric generator is a device which converts mechanical energy into electrical energy. So this is the device which we use to produce large amount of electricity in power stations, etc. So it is a device which converts mechanical energy to electrical energy. So this device works using the principle of electromagnetic induction. Principle of electric generator works based on electromagnetic induction. Namely, when a conductor is moved within a magnetic field, an induced current is produced inside the circuit of the conductor. So this is the principle of electric generator. So let us see the construction of electric generator. So we'll see the construction. So as we can see from the figure, there are two magnetic poles, north and south poles of a permanent magnet as shown in the figure. And then there is this coil ABCD, which is placed between the two magnetic poles. And the ABCD coil is connected to two rings, namely ring 1 and ring 2. So AB is connected to ring 1 and CD side of the coil is connected to ring 2. So inside portion of the ring is insulated and it is connected to an axle which can be moved, which can be rotated by using some outside rotation, which can be turned from outside. Now the other side of the ring is connected to, see the other side is connected to the coil sides AB and CD. So this forms the internal part which rotates the ABCD, the coil ABCD with the two rings. Now we can see two brushes. We can see two brushes B1 and B2. These are stationary and they make touching contact. They just make contact with the brush. And this brushes B1 and B2 forms contact with the external circuit. Here there is this galvanometer and the wire that is given to the external circuit. So these are the basic construction of electric generator. So basically it has a permanent magnet, magnetic poles, then it has coil A, B, C, D, then it has two rings R1 and R2. So these two rings are also known as slip rings. And two brushes B1 and B2 to make external contact. And in this figure, we also have a galvanometer to detect if there is a current is formed or not. So that is the basic construction. Let's see the working. So working of the electric generator working. So as we have seen that it works on the principle of electromagnetic induction. Here, let us first consider the coil, the side of the coil AB. AB side alone, let us consider. So we know that the magnetic field direction is from north to south as shown in the figure. And we also know that the direction of induced current can be found from Fleming's right hand rule. So, and let's imagine that the conductor AB is moving upward. AB is moving upward so that the entire coil, this is the axis of rotation of the coil, and the entire coil, let the coil be moving in the clockwise direction. Coil is moving like that, rotated from outside with the shaft is rotated from outside, and the side AB is moving upward. So by using Fleming's right hand rule, according to Fleming's right hand rule, the thumb will be pointing the direction of the conductor motion. So thumb will point the conductor motion, and forefinger represents the field direction, which means the middle finger, so this is the right hand rule, Fleming's right hand rule. So these thumb, forefinger and middle finger, everything is of the right hand. And in this case, we have to make the thumb, forefinger and middle finger perpendicular to each other. So middle finger points to the direction of induced EMF. We have already discussed the right hand, Fleming's right hand rule in another video. So according to the directions given, we can see that the current inside the conductor, the current inside the side of the conductor AB will be as shown with the red arrow. So it will be in that direction. So the current in AB flows from A to B. So in the entire conductor, if you see in the other side, the CD will be moving downward, and the current is indicated as the this with the same rule. We can see that the current direction will be downward as indicated in the figure. So in the first half of the rotation of the coil, we have the current direction to be A to B to C to D, and then to the brushes and then to the brushes B2, and then in the external circuit it is from B2 to B1. So this is the external circuit from B2 to B1. Now what will happen after 1/2 rotation? 1/2 rotation, after 1/2 rotation, the conductor AB will come this side. So this will become AB and this will be the conductor CD. So in that case, what will happen? In that case, the conductor AB will be moving downwards this time because it is in this position, right? So now the current in the conductor AB, current in AB will be flows from B to A. In the second half rotation. So in the external circuit, if you can see, the current flows from B1 to B2 instead of from B2 to B1. So this clearly shows that in the external circuit, for the first half rotation, the current is flowing in one direction, and for the second half rotation, the current is flowing in the opposite direction. Such a current which reverses its direction every half rotation is known as alternating current or AC. So here basically when we are using the slip rings, we are getting an AC generator. So slip rings are used here, and so we are getting AC generator, which means the generator reverses, which means the current direction reverses every half rotation. Now, what if we want a DC generator? DC generator means the current direction is same every time. So in that case, we use a ring called split ring. Split ring. So split ring, the working of the split ring as a commutator was seen in the topic electric motors. It was studied in detail. So here split ring is nothing but it is a ring which has a two like a complete ring is split into two halves like that, and if one ring is always connected to the conductor. So we can see if this is the ring R1 and this is the ring R2, R1 is always connected to the side which goes up, and R2 is always connected to the side which goes down. So in that case, the external circuit will always have the current in a same direction, or basically we can generate DC current. DC current. So that's the working principle and construction of an electric generator. I hope the topic is clear to you. Meet you in another session.